Hi, I'm Rahul Gupta, Product Manager for Azure Migrate. In this video, I'll show you how the latest tool in Azure Migrate's portfolio can help you containerize your ASP.NET and Java web application and migrate it to containers on Azure Kubernetes Service with minimal to no code changes. The Azure Migrate App Containerization tool looks at the running state of your application to help you determine how to package that application into a container image. You can then use this app container to deploy your application to a container platform like AKS. Before we look at the tool in action, let's talk a little bit about why you may want to migrate your application to AKS and what are the other options that are available to you. There are various reasons why organizations are migrating to Azure. Typically, the migration strategy chosen is really dependent on what the migration triggers are and the expected business outcomes of that migration. When infrastructure-driven considerations such as data center consolidation or hardware refresh cycle are driving migration strategy, the quickest and the most efficient way to unlock business value is to rehost or lift and shift your applications to Azure virtual machines. Once the app is migrated to Azure, you can then progressively embark on a journey of modernizing your application. But when it comes to other considerations such as modernizing your infrastructure and infrastructure management practices that are really driving your migration strategy, there are a few Azure PaaS services that can help out. For web applications, Azure App Service offers a fully managed platform that's purpose-built to help you build, deploy, and run your web applications. The App Service Migration Assistant tool from Microsoft can help you migrate your ASP.NET, PHP, and Java-based web applications and run them natively on Azure App Service. Azure Kubernetes Service is a modern managed infrastructure platform that's the ideal choice for you to run your applications on if you want that extra bit of control over your infrastructure while driving key business outcomes such as improved utilization and consistent management. As you look at migrating your applications to AKS, there are a few different ways you could do this. You could rewrite or refactor your application to adopt a more modern paradigm such as microservices and then run your application as containers on AKS. However, rewriting or refactoring your application requires skilled developers and a level of investment that you may not be ready to make for all your applications. But these other applications could certainly still benefit from a modernization of their infrastructure, and the Azure Migrate App Containerization tool is intended to help you with exactly this use case. The Azure Migrate App Containerization tool gives you an easy way to quickly containerize your application without fundamentally altering the application structure and then migrating that application to a container on Azure Kubernetes Service to realize some of the key benefits such as improved utilization. Let's see how the tool works in a demo. For my demo, I'll be containerizing and migrating a Java-based music streaming application called AirSonic that's deployed in a two-tier configuration on VMware virtual machines on premises. The app tier is a Java web app running on Apache Tomcat, and the application is backed by a database server that's running MySQL. The app stores media content such as music files and downloaded podcasts on the local file system of the application server. I'll be using Azure Migrate's App Containerization tool to containerize the AirSonic app and run it on AKS. The App Containerization tool is a standalone application that you'll run on a machine with network access to your app servers. The machine running the App Containerization tool could be any Windows machine, including a desktop or your laptop machine. The tool has a web-based interface through which you will interact with it, and I've already logged into the tool's web interface here. I've also run through an initial set of prerequisites that validate things like internet connectivity. I've also logged into my Azure account from the tool so that the tool is able to connect to Azure services such as Azure Container Registry and Azure Kubernetes Service that it needs to talk to. At this point, I can specify the server or a list of servers that's hosting the application that needs to be containerized and migrated. I do that by providing the fully qualified domain name or IP address along with the credentials for the application server. The tool remotely connects to the specified server to validate connectivity and credentials. When I click on Continue, the tool starts the process of discovering the list of Java web applications that are hosted on that particular machine. Now, once the applications are discovered, I can select the applications that need to be containerized and migrated. Let me select my AirSonic application. I need to specify the name to be used for the container image that's built for this application. I'm just going to call that AirSonic and attach a label to this image. Now, the other cool thing that this tool can do is it detects the application configuration such as database connection strings. For example, here the tool has identified that this application has a backing database, and by looking at well-defined connection string patterns, it's able to identify the database connection string configuration that is there in the config file for this application. It's now giving me the option to parameterize this such that I can make it a deployment time configuration. That way, I don't have to rebuild the container image every time I need the application to connect to a different database, or if I need to test the application before I actually do the migration. The tool also automatically detects the application files and dependencies that need to be packaged into the container image for the application. But there may be additional customizations that you may need. You may choose to copy some specific directories or folders from the server other than the ones that have been detected by the tool. For example, like I had mentioned earlier, the AirSonic app stores media content such as music and podcasts to be streamed on the application server's local file system in a separate directory called /var/AirSonic. To include this directory and contents with the container image, I edit the application folders section and specify the list of additional directories and folders. I can choose to keep these additional directories in the container image, or I could externalize them to persistent storage, which can also help me reduce my container image size and improve performance. This particular feature is also useful to let me scale my application by adding multiple replicas, with all replicas working on the same shared content folders accessed through this particular persistent volume. Now that I'm done with my application discovery and I'm ready to build the container image for the application, I'm just going to select an Azure Container Registry that I can use to store or publish the container image that gets built. I have the option of creating a new container registry from within the tool itself, but I'm going to go ahead and select an Azure Container Registry that I already have. At this point, the tool, based on detected application configurations and other selections that we made, generates a Docker file that I can use to build a Docker container image for this application. The Docker file generation uses a set of base values for things such as the image to use. Other properties, such as the ports to expose the application on, are detected based on the discovered application configurations. I have the option of performing further edits and customizations to the Docker files before using it to build the container image. I'm just going to stick with the base Docker file that was generated and use that to build out my container image for this application. So let me click Build. At this point, the container image build process has started. The image build itself happens in Azure Container Registry Service by using the tasks feature of Azure Container Registry. That way, I don't have to install Docker tools or any additional tools on the machine, and I can simply use the build logs that are generated here to monitor the progress. Now that the application's container image is built, I am ready to start generating the Kubernetes definitions and manifest YAML files that are needed to deploy this application to AKS. To do that, I'm going to select the AKS cluster that I wish to deploy the application to. If I'm trying to run a quick proof of concept, I have the convenient option of creating a new AKS cluster to deploy the application to from right here in the tool. I'm going to stick with the previously existing AKS cluster that I already have. Since I selected the option to use persistent volumes with my containerized application, I need to specify an Azure file share that the tool can use during the migration process to upload data that needs to be stored in the persistent volumes. The tool uses this file share as an intermediate store for content that needs to be moved over. I then specify the other application settings that are needed to generate the YAML files by clicking the configure button here. As you can see, I have a few different options here. I can specify a prefix string to use for the Kubernetes resources that are generated and the number of replicas to begin with for the app. If the application is an internet-facing application, I want to select an external load balancer for the service, or if it's an internal application, I just want to select internal. Let me go ahead and select external for now. The next piece here is the database connection string that I had parameterized before building my application's container image. I use this parameter to specify details of the database that the application deployed in AKS should connect to. For example, I may want to perform a test right now using a test copy of the database before uploading the application to connect to my production database. For my demo, I've already created a test copy of my on-premise database in Azure on an Azure database for MySQL instance. I'll use this test copy of the database to test out my application first before redeploying the application with the app parameter set to connect to my actual production database. So let me go ahead and do that. Finally, I can review and specify whether my persistent volume should be shared across application instances in the container, or should each instance have its dedicated persistent volume for the file system dependencies that we chose to externalize. I'm going to leave this as shared for now and go ahead and save these configurations. When I hit the continue button, the tool will generate the Yaml files that specifies the various Kubernetes artifacts that are needed to deploy the application to AKS. Here again, I have the option of further customizing the YAML file before I use it to deploy my application. As you can see, the file has both the deployment spec for the application using the container image that was just built, as well as the service spec for the load balancer that needs to be created. I'm just going to stick with the defaults, and at this point, I can either take these generated artifacts and use that with Kubernetes CLI to deploy the application, or I can use the deploy button here to kick off the deployment process. So let me go ahead and do that. What this is now doing is, it's using the Kubernetes API to start creating the artifacts defined in the YAML file that were generated by the tool. The application deployment is now complete. As you can see, the application is now deployed to AKS and can be reached on this public IP address. Let's see if I'm able to access the app on this IP address. So as you can see, I was able to take an existing Java application that's running on a Linux server machine and in a few steps successfully containerize it and get the application deployed on Azure Kubernetes Service. To recap the demo that you just saw, the Azure Migrate App Containerization tool is a standalone tool that can run on any Windows machine. The tool can remotely connect to a Linux server running your Java web application that you're looking to containerize and migrate to AKS. The tool will identify the application components that need to be packaged together into the container image and generate the Docker file that can help you build that container image. You can use the Azure Container Registry's remote build feature to build your application's container image and even push it to your container registry. The tool will then generate the Kubernetes manifests that are needed to deploy the application to AKS. The customizations built into the tool will help you parameterize your application configurations and even move app contents out of the container image into a persistent volume. The artifacts generated by the tool, such as the Docker file and the Kubernetes manifest, can be downloaded, saved, and further used for day-to-day operations. To learn more about the Azure Migrate App Containerization tool and our roadmap, reach out to App Containerization at Microsoft.com.